yesterday was we were solving this equation, right? Where it's just a quick review. We talked about what's a chord, what's a secant, what's a tangent. A chord just connects the two sides of the circle. Doesn't necessarily go through the middle, but it goes from edge to edge. A tangent touches the circle in one spot, like that. And a secant goes through the circle like that. It intersects the circle in two different points. It's a line, okay? Then radius, I feel like we knew that already. That's where from the center of the circle to the edge. And a diameter, what's another name for a diameter? I'd say chord, could. And it goes through, it touches the edges, but it goes through the center of the circle. That's what makes it a diameter instead of just a chord, okay? Then we talked about congruent circles, concentric circles, and tangent circles. Tangent circles touch in one spot. Concentric circles don't touch, but they share a center. And then congruent circles have equal radii, and equal radii mean they're congruent circles. And then we wrote an equation for a graph, right? We found the point of tangency, like this was -2, or 2, -2, and then we came up with an equation of that line, y equals -2. And then we started talking about the meat of this section, the last target, which is to talk about the relationship between tangent lines and radii. So we said if a line is tangent to a circle and you draw a radius to that point of tangency, it makes perpendicular lines. Okay? And the opposite is true. If you've got perpendicular lines, then you know that that line was tangent. Right? And we also said, and I believe we already covered this too, right, in this class? We said if you draw a tangent line to a circle from two tangent lines from a single point. So this segment starts at A and goes to the point of tangency. This starts at A and goes to the other side, point of tangency. Call it like the ice cream cone theorem because it looks like an ice cream cone. That these two tangent line segments are equal. And so we use that to solve this. And what did we know about these two equations? Exactly. So we said 4a plus 2 equals 5a minus 32. And so we subtracted 4a, added 32, and I got 34 equals a. And now, but they ask for the length of GH. So how would I find the length of GH? Exactly, you'd plug it in. 4 times 34 plus 2. 4 times 34 is 120, 116, 136 plus 2. So that's 138. Okay? And then what if I wanted to know KH? How could I find that? Plug it in. What would be an easier way? An even quicker way? Yeah, they're equal. So we already know. We could plug it in. If we wanted to check, we could plug it in, make sure we got 138. But I already know that KH has to be the same as GH. So they're both 138. Okay? And then, thank goodness, they've taken indirect proof off Common Core standards. So we don't have to learn indirect proof for Common Core, but it might be on the ACT Quality Core test. So I just want to go over it. We're not going to write them. We're not going to do them, but I just want to tell you what they are. So if you come across one on the test, you'd know what they are. So an indirect proof, normally in a regular proof, we'd be given A and we're trying to prove Z. So we'd say if A then B, if B then C, if C then D, if D then E, all the way to Z, right? And that's how we'd prove it. We'd just go step by step and say, if this is true, then this is true. If this is true, then this is true. Okay, well, an indirect proof, okay, it's called indirect because we can't just go straight down. We start by saying, okay, I really don't have a way of proving that line L is perpendicular to AB. So what I'm going to do instead is prove that line L can't be not perpendicular to AB. Okay, like there's a lot of negatives in there, I know. So what we do is we say we are going to try to prove that L is not perpendicular to AB. Okay, and then something bad is going to happen in the proof. We're going to be going along our merry way doing A, if A then B, if B then C. We're going to be just regular old proof, except all of a sudden we're going to get a statement like 1 is greater than 5, or something like crazy that can't possibly be true. Okay, so if that's how it ends, then we can say, well, it's impossible for L not to be perpendicular to AB, therefore it must be perpendicular to AB. Do you see what the difference is between an indirect and a direct? Like I said, you're not going to have to do it, but you do need to know what they are. So like, let's say for this one, for example, so we were trying to prove that L is perpendicular to AB. So I first assume that L is not perpendicular to AB. Okay? So if you look at this picture, we're assuming that this is not perpendicular. So if it's not perpendicular, wouldn't there be a way to put C on this line so that it would be perpendicular? Okay? So we're going to say, okay, if A and B is not perpendicular, then we're going to say CA is perpendicular. Okay? So if CA is perpendicular, then can't I make a right triangle? If that's C and then that would be B and that would be A, right? And in that case, CA would have to be less than AB, right? Okay? So if AB is a tangent line, or sorry, if L is tangent, that means that B has to be on the circle, right? So if B is on the circle and it's the only point, remember tangent lines only you're allowed to have one point on the circle? So if B is the only point on the circle, doesn't that mean that C can't be on the circle? And so doesn't that mean that the length of A to C has to be longer than the length of A to B? So it can't possibly be true that AC is less than AB. Okay, so there's that thing I told you that was going to fall apart. You know, there's no way that AC can be shorter than AB. So therefore, if that's impossible, then it's impossible for L not to be perpendicular to AB. And if it's impossible for it not to be perpendicular, then it must be perpendicular. Okay? So that's how an indirect proof works. Right? You go through a proof headed for the wrong goal, but you hit a roadblock, and because you can't get past that roadblock, the opposite of what you're headed toward must be true. Okay? Does that make sense? Like I said, you wouldn't have to write one from scratch, but you'd have to recognize an indirect proof. And it might even be something like, given this proof, or given in this proof, write the statement you would have to prove for an indirect proof. So you'd have to say L is not perpendicular to AB, right? Okay, and if I were going to say prove that ABCD is a square, what would be the indirect proof version? ABCD is not a square, right? You just take whatever it is and flip it. Or if I were trying to prove that circle F and E are not tangent, then I would say, to do an indirect proof, I'd say yeah, A and E are tangent, right? Okay? Does that make sense? Like I said, thank God we don't have to do this anymore. We just have to, we can skip that, just know what it is. Okay, this is way more fun. All right, so this is a satellite. This is the Earth, in case you couldn't tell. Okay, this is actually, I know I keep talking about NASA, but this is actually something that NASA does. They check if you look from the satellite to the Earth, this is the horizon, right? So as the Earth turns, the satellite keeps showing up on the horizon, like all the way around, right? As it rotates. Okay, and I want to know what the distance is from the horizon to the satellite. So take a minute and see if you can figure that out. Given what we just, so what do we know about a tangent drawn to a radii drawn to a line of tangency? It's perpendicular. So what shape did I just make? A right triangle, my favorite shape, our best friend, because there's so many things you can do with a right triangle. What are some things? What can we use with a right triangle? Pythagorean theorem. What else? Yeah, trig, SOHCAHTOA, right? We can do similar right triangles. We can do lots of stuff with right triangles. So whenever I see a right triangle, I think, yes, because I can do lots of stuff with it. Which one are we going to use for this? Pythagorean theorem. Okay, so these are the legs, 8 and x. So 8 squared plus x squared equals, okay, what's the length of hypotenuse? Yeah, can it be 7? Why not? Yeah, what is this called? The radius, right? So the radius has to be what? 8. So this whole side has to be longer than 8. Okay? If this were 12, I wouldn't be positive that wasn't the whole length. But since it was less than 8, I knew for sure it wasn't the whole thing. Does that make sense? Okay? So the whole length of the hypotenuse is 15. Okay, so I do 64 plus x squared equals 225. I subtract 64, and that gives me x squared equals 161. And then how do I solve it? Square root, good. Lanier, this would be one of those times when you need a calculator. What's the square root of 161? Round it correctly? Good. 12.69. Okay? So x would be 12.69. And this is actually like programming I wrote, or helped write, I didn't write it all, for NASA, because there are stations all over the world checking to see that if this distance, if this satellite's traveling around the world, doesn't the distance when it hits the horizon have to be the same? So they know exactly what time it should appear on the horizon. Okay, so this is from here to here is the distance a satellite is from the Earth. This is to the center of the Earth. It's not 8, but I didn't want you to have to deal with those giant numbers, so I just made it 8. But we know ever since we got to go out in space, we saw how big the Earth is, so we calculated the radius. So we know what the radius of the Earth is. So we knew exactly when all around the Earth, when this satellite should show up on the horizon. And if it doesn't, that means that the distance is off. So that could mean that it got hit by a meteor and it is off a little bit, or it's the rotation, or the, what do you call it, around the Earth? The orbit, thank you, is off a little bit. Like it might be degrading. We call that degrading because it's slowly, eventually it's going to fall to Earth because it's slowly starts to degrade. So that's how they keep track. They just track it all around the Earth to make sure that it's showing up on the horizon right when it should. Does that make sense? So you see these all the time on like standardized tests, I think because it actually has a real life application. So like on the ACT Quality Core, or was it on the OGT this year? Or do we have any sophomores in here? Sometimes it shows up on the OGT. So you'll see the this problem occasionally. All right, does that make sense though? Okay, awesome.